Hello everyone, my name is Taofiq Huq and I'm founder and CEO of Spiral Blue, a Sydney-based Earth observation startup. Our mission is to use space technologies to help the Earth. So what does this have to do with making Earth observation satellites smarter? Well, let me start with a bit of a story about myself. I studied aerospace engineering at the University of New South Wales, having wanted to work in space since I was about 10. I wanted to work in the space industry in Australia specifically. To do this, considering there wasn't much of a space industry at the time, I figured I either needed to create my own company or do a PhD. So of course, I had a crack at both at the same time. And given the position from which I'm speaking with you all today, the startup did a little bit better than the PhD. But why did I want to work in space in the first place? Well, like many, I was captivated by the beauty of the universe as a child. But as I grew up, I realized that space actually held far greater promise than just, some pretty pictures. I realized that space holds promise for Earth and the people on it. Going full science fiction for a minute, if we ultimately develop the ability to terraform other planets, we will be able to solve many of the problems we face on Earth today. And for the Q&A later, if anyone can tell me what these planets are, these terraformed images, that would be interesting. Sorry, just got a call. So moving on, climate change, deforestation, desertification, hunger, overfishing, pollution. I could go on and on. These are just some of the problems that we face on Earth today. Our mission at Spiral Blue is to tackle these problems with space technologies. And so quite naturally, working in the Earth observation domain, because Earth observation gives us the opportunity to better understand and thus develop solutions to these problems that we are facing. After all, you need to measure before you can manage. But there are some problems that we've identified with Earth observation satellites. For instance, they can capture far more data than they can actually bring down. This means that this drives up the price of high-quality satellite imagery, putting it well outside the reach of almost anyone but government agencies and large companies. Even worse, satellite imagery is complex and hard to work with, as many of you will know. Specialized skills and infrastructure are needed to process and interpret this data, with ultimately many users just want information. So what needs to be done? We believe that in Earth observation, getting information from satellite imagery needs to be as easy as, well, Google. Just think for a moment if we could get yield estimates, financial predictions, or early warnings of suspicious activity as easily as we look up the weather. But this also needs to be so cheap that we don't even think about the cost. I don't think anyone here worries about paying $15 a year in tax to pay for the Bureau of Meteorology. They do fantastic work. But to make this possible, we need a massive increase in capacity. So how are we going about this? Well, we believe that the first piece of this puzzle is our space edge computing technology. We are putting what are effectively miniature supercomputers on Earth observation satellites to help reduce the cost of getting Earth observation insights. We do this by processing images on the satellite and bringing down information, processed information, instead of just raw data. There will, of course, be applications where we still need to bring down raw data, as will be discussed later today, I'm sure. But if we can bring down information, this enables a potential 20 to 100-fold increase in satellite capacity, helping to reduce costs, reduce lead times, and remove minimum order quantities. We're doing this by adapting NVIDIA edge computers for operation in space. We're working on custom interfacing, thermal control, radiation shielding, as well as secure onboard software, which are, we believe, the key components to make this technology possible. And to bring it all together, we're providing access to space edge computers on Earth observation satellites through our Space Edge Services platform, being developed partly through the support of the Australian Space Agency. We're looking at an App Store type model where you can select an area of interest, a time to conduct imaging, and then one or more apps to do the image processing with. You can even upload your own apps for others to use. We're developing this platform to enable automated tasking of satellites carrying space-age computers in a secure and upgradable manner. After all, the last thing we want is someone uploading a bit of code that causes a satellite to turn around and start heading for the moon. We've had a few big wins today, I'm proud to say. We've won a contract from the Australian Defence Innovation Hub, as well as a grant from the Australian Space Agency, on top of investment that we've kindly received from friends and family. Here's a photo, in fact, that we had with the new Space Agency admin, Enrico Palomo, when he visited earlier this year. And we've just had our first launch with Sat Revolution just last month, with 2 satellites launched, each carrying a space-age computer. We're currently waiting on the satellites to be commissioned before we start getting results. And we have yet more launches planned for next year with a variety of providers. We're launching with Satellogic from Argentina, Modularity Space in the United States, and Australia Space Machines Company. We intend to open a closed beta for Spacehead services later this year and an open beta next year. If you're interested in helping us democratize Earth observation so that it's available to everyone, please feel free to reach out. That'll be all for now. Thank you so much for listening.